Hi, this is Lekana. Today I am here with the topic that is probability mass function and distribution. The content of today's videos are probability mass function, example of problem mass, applications of problem mass, probability distribution. Example, problem of probability distribution, applications of probability distribution. First we have this probability mass function. Probability mass is defined as a function which gives the probability that discrete random variables is exactly equal to the same value. It is also known as discrete probability density function. The probability mass function is often the primary means of defining a discrete probability distribution, and such function exists for either scalar or multivariate random variables whose domain is discrete. If for each value f of x of a discrete random variables x, we assign a real number p of x such that p of x is greater than or equal to 0. If the probability that x take the value xi is pi, then p of xi equals to xi and pi equals to pi or p of xi. The set of values xi comma p of xi is called as discrete or finite probability distribution of discrete random variable x. The function p of x is called a probability density function or the probability mass function. Mean is calculated by the following formula: summation xi into p of x. Variation is calculated by the formula summation xi whole square p of x minus mu square. Next we have problem based on the probability mass function. A coin is tossed twice. A random variable x represents the number of heads turning up. Find the discrete probability distribution for x. Also, determine its mean and variance. S is equals to sample 2 times h, h tail, head tail, tail head, tail tail, and s is equals to 2, 1, 1, 0. You can see x is 0, 1, 2 and p of x is 1 by 4, 1 by 2, 1 by 4. P of x equals to 0 is equals to 1, 1 divided by 4. P of x equals to 1 equals to 1 by 2. P of x equals to 2 equals to 1 by 4. Mean is equals to summation xi into p of x, that is 0 plus 1 by 2 plus 1 by 4 equals to 1. Variance summation xi square p of x minus mu square is equals to 1 by 2. Next we have what are the applications of probability mass function. Applications are as follows. First is statics and data analysis. Second we have quality control. In statics and data analysis, PMS probability mass functions are used extensively in the statistics to analyze and model discrete data. They help in understanding the likelihood of different outcomes in scenarios such as survey response, game outcomes and product defect rates. In quality control, we use this probability mass function. It can be used in manufacturing processes. Probability mass functions can model the probability distribution of defective product or faults in the production line, aiding in quality control strategies. And next we have probability distribution. A probability distribution is a mathematical function that describes the likelihood of different outcomes or events in a particular scenario. It provides a way to quantify uncertainty by assigning probability to various possible outcomes of a random experiment or a random variables. Discrete probability distribution. This type of distribution is associated with discrete random variables which have a countable number of possible outcomes. Example includes the binomial distribution, Poisson distribution and geometric distribution. Continuous probability distribution. Continuous probability distribution applies to continuous random variables that can take any value within a specified range. Example include the normal, Gaussian distribution, exponential distribution and uniform distribution. Example for probability distribution. You can see this data. X equals to 10, 20, 30, 40 and p of x is 1 by 8, 3 by 8, 3 by 8, 1 by 2. Show that following this distribution represents a discrete probability distribution. Find the mean and variance. We observe that p of x is greater than 0 and the sum of p of x equals to 1. Mean obtained for this data is 25 and the variance obtained for this data is 75. Applications of probability distribution. We can see this probability distribution applications in the field of engineering and physics, in telecommunications and networking, in the machine learning and data science. How it is used in engineering and physics. In engineering, probability distributions are used to model the reliability of systems, failure rates and lifetimes of components. In physics, distribution describes phenomena such as particle decay, energy levels and quantum states. In telecommunications and networking, probability distributions are used to model data traffic, packet arrival times, and signal strength variations in communication networks. They aid in designing and optimizing network protocols and resource allocation. In machine learning and data science, probability distributions are fundamental in machine learning for modeling data and uncertainty. They are used in various algorithms like Bayesian mixture model, hidden Marconi model, and Bayesian interface model. Thank you for watching my video. Please do like and share the video.